Hey guys, yesterday we worked on this sheet and we were writing chemical equations. Today we are going to come back to this sheet and we are going to learn how to balance equations. So there's actually nothing in your notes on balancing equations for this. I'm just going to teach it here with a couple of examples on this sheet, and you can finish this worksheet then today. Okay, so when we balance equations, we have to make sure that the same number of things on the left side of the equation are present on the right side of the equation. So what I always like to do is I like to make a list over on the side of what I have in a chemical equation. So in this one I have iron, I have carbon, and I have oxygen. So if we count them, over here on the left side of the chemical equation, I have 2 irons. On the right side, there's only 1 iron. On the left side of the chemical equation, I have 1 carbon. On the right side of the chemical equation, I have 1 carbon. On the right side of the the left side of the chemical equation, I have 3 oxygens plus 1 oxygen here. So there's 4 oxygens total on the left. And on the right side, there are 2 oxygens. So the goal with a chemical equation, like we said, is to balance it, to make it the same on one side. And you do that by adding coefficients. So that's the numbers in the front, okay? So I know that I'm going to need more iron on the right side of the equation. If I look here, the iron on the left is 2, the iron on the right is 1. So I need to make more iron here. So if I put 2 iron here, then I have 2 iron on the left and 2 iron on the right. And so that's perfect, okay? Now, my carbon is good, but my oxygen is not good. So I need more oxygen on the right side of the equation. So the way that I can do that is I could put a 2 here, okay? When you don't see anything, there's technically a 1 there. So adding 1 is not going to do anything, but we can add 2. So if I put a 2 there, not only am I going to get more oxygen, but I'm also going to get more carbon. So that gives me 2 carbons then on the right, okay? And then it's going to give me 2 times this 2, it's going to give me 4 oxygens on the right, okay? So now my oxygen is balanced, but my carbon is out of whack, okay? So let's go back over to the left and get another carbon. So if I get 2 carbon there, that's going to fix my carbon problem, but it's going to give me an oxygen problem. So now on the left, I have 5 oxygen, okay? Man, so I'm going to need more oxygen on the right. So let's up this 2 here to a 3. This can get a little messy, okay? So now I'm going to have 3 carbon and 6 oxygen, okay? So my iron's good, but my carbon and my oxygen are both still off, okay? Well, since I need both carbon and oxygen, I'm going to adjust this one, okay? You could adjust the oxygen here, but that's not going to fix the carbon problem. So because I need to fix the carbon problem too, sorry about that, then I'm going to change this 2 to a 3, okay? So now I'm going to have 3 carbon and 6 oxygen. 3 oxygen here, 3 oxygen here. And so it looks to me like everything is balanced, but I always like to go back through one more time and double check. I have 2 irons and 2 irons. I have 3 plus 3 oxygen, which is 6 oxygen, and 6 oxygen here. I have 3 carbons and 3 carbons. So this is correct. Okay. Iron oxide plus 3 carbon monoxide yields 2 iron plus 3 carbon dioxide is the balanced chemical equation for this. Okay. I'm going to do a couple more with you. This one wasn't super easy, but it also wasn't super hard. Some of these get really hairy and can have really big coefficients here. Okay. So you may find that it's easier to kind of do this on a scratch piece of paper and then transfer your answer over so it doesn't get quite as messy as mine does. Granted, I wasn't erasing, and you can erase a little easier, but it may be a little bit easier if you do it that way. Okay, let's look at the next one. Potassium chloride. Okay, I'll also say this is where it's very important that you have written your formulas correctly. Had you not have written iron oxide correctly as Fe2O3, then your balancing would be totally off. Had you have just written iron oxide as FeO, then all of your balancing would be wrong. Okay? So, if you would like to email me your completed, just to send me a picture of the written out equations. If you send me a picture of that completed, I will send you, I will check them and see if they're correct. And so that way then you know that you're not doing a lot of work and to make a mistake. You're not going to be doing your pointless work because you're not set up correctly, if that makes sense. So if you want to take a picture and send it to me before you balance it, then I'll check them real quick before you balance them. Okay? So let's go on with this next one. Potassium chloride plus silver nitrate. Okay? And I know that I've written those correctly. Yields potassium nitrate plus silver chloride. Okay? So again, I'm going to set up all the things that I have. I'm running out of space. It's not letting me right up there. Okay, AgCl, NO3, because it's a polyatomic ion, you can separate it out into N and O, or I think it's easier to look at it as one thing. Okay? Potassium. So I have 1 potassium on the left. I have 1 potassium on the right. Okay? Chlorine. I have 1 chlorine on the left and 1 chlorine on the right. Silver. I have 1 silver on the left and 1 silver on the right. And nitrate. I have 1 nitrate on the left and 1 nitrate on the right. Okay? And that balanced perfect and easily. Okay? So that one was already balanced. Not all equations will have to be balanced. Okay? Some of them will naturally just be balanced with ones.